So good morning, everybody. My name is Razlin. I am presenting from Lismore, Wujibun country. Hopefully I haven't butchered that presentation. So as Shay said, this is the topic of my presentation. I am almost finished with my PhD. I just submitted and I'm waiting comments back on my thesis. So since I've never done praxis, I thought, no better time than the present. So my presentation covers quite a number of concepts. So the main concepts here are underutilized crops, nutrition, nutritional data management, as well as de novo analysis of nutritional composition. So in our current global food supply, more than 75% of our food actually comes from only 12 plants and 5 animal species. And when we're talking about food crops, 3 major crops being, not major, but more staple crops being rice, wheat, and maize actually provide more than 50% of the calories and nutrients in human diets. In addition, these 3 crops are also used as animal feed. So this then creates an over-reliance on a very, very small number of food crops for both food and feed for animals and humans. This then leads to an unstable food nutritional security. So if you can imagine food nutritional security as a ball that's balancing on the apex of a very, very small triangle, it's very unstable right now. This also leads to erosion of agrobiodiversity and loss of diet diversification and traditional diets, which is quite ironic because throughout human history, there have been more than 40,000 plants that have been used in some form for food or fodder or for medicinal purposes. And at current climate, we consume less than 200, and that includes all these minor crops and underutilized crops, which is what I have been researching for the last almost 4 years. So underutilized crops, or UUC, as I also call them, is used as an umbrella term to also include crops that we know as minor crops, orphan crops, also indigenous crops, crops that have been neglected, also wild relatives of major species. So if you have a wild relative of a soybean that's not really used that prevalent, is also considered an underutilized crop. So these crops are characterized by the fact that they're not traded globally. So usually you only find them in home garden, in little markets in different districts. They also have very low production levels. They are cultivated mainly in subsistence farms, as well as home gardens, mainly by rural poor in many developing countries. There's very limited research because very limited funding, because there's not much attention paid to these crops. However, they do have a very strong gender component, being that these crops are mainly cultivated and sold by women farmers in small markets. So there is a very important cultural and economic value to these crops for women, because as you know, anybody that studies socioeconomics would tell you that when the woman in the household is empowered, she's then able to make decisions that will better the life of her children. So in terms of underutilized crop and food and nutritional security, the question is, how can we then, how is it possible that we can integrate more underutilized crops into global food and nutritional security? Well, to do that, we need data. We need a lot of data because there's not a lot of data out there. So more specifically, we need data on nutritional composition of these crops. We also need data that describes the range of variation for each nutritional composition that is attributed to genetics, to environment, and also the interaction of genetics and environment, but also how the crops are processed and how they're made into food products. It's also important that we include comparison to major crop species. So for instance, if I want to research millet, which is an underutilized underutilized cereal, therefore I could include wheat and rice as a major cereal equivalent to see whether or not a millet could be used instead of wheat and rice from a nutritional perspective. So in order to combat and try to resolve all those gaps that is there, I've come up basically with a systematic workflow. So this is basically encompasses my entire thesis over all my research chapters. So we have 3 major components. You can kind of ignore the last one, which is applications, because that is not really part of the workflow. That's just an application of the data that we got from the workflow. So it spans 3 different kind of areas, from literature review to data management to de novo analysis. So to develop the workflow, we need a crop that we can use that is kind of, you know, not really very obscure, that you can't get any any varieties from it. So the crop that we've used to develop this systematic workflow is an underutilized legume that's indigenous to sub-Saharan Africa called the bambara groundnut. So if anybody here is from Africa, they would probably know this crop because it's actually quite famous as being, you know, a traditional food in many areas in Africa. So this crop is actually perfect to be used because it's a drought-tolerant legume. It grows on actually marginal soil with very little need for fertilizer or water. And actually, it's a very important plant-based source of protein, minerals, as well as dietary fiber and fat for many rural poor that cultivate the crop. So keeping in true with using comparative species, I choose 4 major or commodity crops as my comparative species: soybean, chickpea, cowpea, and mungbean. These are all closely related to bambara, phylogeny-wise, the closest being cowpea and mungbean, both being Vigna, in the Vigna genus. So, but hold on a second. Traditionally, underutilized crops like bambara groundnut was consumed in stews, was made into a paste and steamed into a cake, or even like canned, so it can be preserved for a little bit longer. Also consumed as snacks, either boiled, steamed, or fried. However, with the future, we have a lot of innovation that's going on. So in the last decade, there's seen quite a number of increase in innovative food products using underutilized crops like bambara groundnut. So you have everything from bambara milk to biscotti. We use panna cotta. They even have a cultured milk drink, and also, very interestingly, instant noodles that has been developed by a company in Singapore called Namzi, and is sold in the UK by a company called What If Foods. So it's not just bambara groundnut, but they also do other underutilized crops such as moringa or the drumstick tree. And also, it's very important to have this kind of innovation and involvement of the food industry, because then if you take, for instance, a company called Believe in Bambara, which is the second little icon you see down there, it's a company that's based on the fact that they source the bambara beans from smallholder farmers in Ghana directly. So therefore, the smallholder farmers, which are predominantly women, have guaranteed buyer for their crops. So therefore, they can increase their planting without fear that they won't be able to sell their crop, and their crop is paid at a competitive market rate, which then guarantees them constant income for the season that they can plant bambara, and then the excess is kept for either home consumption or sold to markets, or they can use it to exchange seeds with other farmer cooperatives in the area. So this project is based in Ghana, and it has a collaboration with the Ghana Agricultural Ministry, which is great because, you know, for a company to go into Ghana, especially because this company is based in America, for a company to go into Ghana, it's not easy, especially to engage smallholder farmers on a traditional crop such as this. So moving on, I'll describe each part of the systematic workflow. So there's 3 parts. So I'll describe how it was done, and then I'll share some of the results that we managed to get and how this will help with the nutritional composition of underutilized crops. So the first component is the literature review. I know literature reviews are like standard for PhD, everybody does it. However, literature review on a crop usually would only focus on 1 crop. But for my literature review, I had to focus on 5 crops. So it was like doing a literature review on 5 legumes. The focus was more on bambara, but I had to get data to compare with every single one of my comparative crops. So that's why I ended up with like 133 data sources. And I ended up with very, very large data sets and Excel sheets, which was really great because that allowed me to have very nice representation graphics such as this. So you can see that bambara groundnut, this is just the major nutritional components of the seed. You can see it's very similar to what we find in cowpea, mungbean, and chickpea, which is quite expected because these are all considered grain legumes. A bit different than soybean, because soybean, is like the gold standard of legumes, which is what bambara will never be what soybean is, but it could get halfway there with enough research development and innovative thinking. So using the literature review, I managed to generate a nice box whisker plot. You can see what the range of variation is from literature across the 5 species. As you can see, as I said, so you can see that the seed protein is a very important component for food crops, as well as plant-based food source. So we can see that bambara has quite a large range of variation in its seed nutritional seed protein. It ranges basically from 9 to 30% of the seed, which is quite a large variation, mainly attributed to genetics and the growing environment. So you can see it actually is higher than both chickpea, cowpea, and mungbean as well, but nowhere as high as soybean, but that's a given. I also have to stress that the data that I use for bambara groundnut is mainly gathered on traditional land races and varieties that have not had any selective pressure to select for nutritional composition. So then moving on, we have some data on fatty acids. So fatty acids are very important components of lipid. So omega-3 and omega-6 fatty acids are very valuable in terms of human health. So for bambara groundnut, the major fatty acids that make up their fat is linoleic and oleic acid, which is really great because they're polyunsaturated fatty acids. And we can see that even for oleic acid, the literature says that it actually has a higher concentration than soybean, and this will be the soybean that has not been genetically modified for oleic acid. So inherently it has quite high amount of oleic and linoleic acid, which is great for polyunsaturated fatty acid intake. So from the literature review, to summarize, using a more comprehensive multi-species approach, I was able to find that there's limited or even absent data for a lot of nutritional components for bambara groundnut. So a lot of protein fractions were either being albumin globulin, which is important for ratio of amino acids, is very lacking. There's also not a lot of data on dietary fiber fractions. This is actually quite important in terms of resistant starch. That is important for management of diabetes and cholesterols. Very little information on anti-nutritional factors, phytosterols, and almost nothing on secondary metabolites. So it's quite a challenge because there's so little amount of data around. The major components have quite a lot of data, but the minor components are very little amount of data involved. From the literature review, we also established that there is sufficient variation within the global gene pool to develop high protein cultivars or to improve the concentration of specific fatty acids such as linoleic and oleic acid, which have health benefits. And an important thing is that because it's so closely related to crops like chickpea and cowpea, which have had quite a lot of investment, quite a lot of improvement in terms of their nutritional as well as agronomy, we can use similar approaches, so we don't have to reinvent the wheel. We can just use the wheel that's already there for other legumes and just kind of hitch a ride and, just try the approaches that have worked. Not everything will work, but most of it will work because they're quite similar in terms of their agronomy as well as their nutritional composition. So the second part is a data curation. So this actually came about because because a lot of the
one minute, Razlin.
Okay. So this came about because there's not a data management system for nutritional data. So that's why we had to create our own, and also there is no ontology for nutritional data. So this is how it was. There's 2 classes that we came up with: nutritional and dietary function. I can't go through everything because I'm a little bit lacking. And this is how we envisioned that the thing that I came up with would fit into the larger picture to help with nutritional data as a whole. So the third one is a de novo analysis. So it was important that we gathered enough genotypes that would allow us to do a comprehensive analysis. So 100 genotypes were sourced from all over the world. And we did nutritional composition, proximate, starch, fatty acids, did some heritability analysis as well as G times E. And we see that in comparison to literature, actually the actual values is a bit lower with a smaller range of variation, which is quite kind of expected. But then it kind of gives us a very solid, I guess, platform that we can lobby for the nutritional composition of this crop. We can also see that for the PCA, I did a PCA because I thought that the protein and lipid would be inversely correlated, but actually isn't, which is great because then now we can increase the protein and the lipid at the same time without a negative effect. And for fatty acids, we can also hopefully increase either linoleic or oleic, but however, they're negatively correlated, so we have to keep that in mind. But we are able to increase it if we can, and I think it's able. And so in conclusion, using a multi approach, you kind of like get more information than just if you just did a purely nutritional, purely agronomy kind of project. So with the outputs, hopefully the outputs will all then contribute to a systematic framework that can be used not only in bambara but other crops as well, that can then give us enough data that we can, propose that these crops are more heavily introduced into areas and more incorporated into global diets and food systems. And that is me. Thank you very much.
Thank you so much, Razlin. What incredibly wonderful and incredibly important research you're undertaking. I'm shocked to learn that there are so few species of plants that we're actually using, and yes, it creates a lack of security, doesn't it? And
oh yeah,
my very first question I was going to ask you about, because you said that women were generally the traditional farmers of these underutilised crops, and I wondered what would happen in the transition to them being more utilised, whether women would lose that power base in their communities. But you did mention one program that was making sure that the women were the financial recipients of the work of their crops, because I've seen in situations that they can be taken over if there's suddenly a market. So I just wondered if there was something else you could say about that, because that's a very important.
So traditionally, when it comes to African smallholder communities, the men would grow cash crops such as cotton or maybe even peanut. So the women then are left with these, small crops, minor crops, home gardens. However, I do see that if bambara ever becomes as big as quinoa ever does, which I don't think it will, there might be a risk that there might be a power struggle, that the male farmers would then transition to cultivating this crop if it becomes a cash crop. But I think as long as we have all these social enterprises and we have companies that keep in mind that smallholder farmers and gender empowerment is part of their motto and have that built into their company, I think that the women farmers hopefully will not be too much sidelined. I think, you're right, there will be some shift for sure, but hopefully, then you can train women to process them or maybe come up with other things that women are very good at, like maybe the packaging or even like, processing or just making a really nice fabric to go with the packaging might also be one way of doing it. It's actually incredible how much innovation has actually gone into traditional crops like bambara groundnut, and it's also because there's a lot of diaspora community more than ever, I think. So people want a taste of home. So I'm like from Malaysia. So the thing that I want the most when I'm, here, I'm like, oh, I want my Malaysian, sweets, and I need to buy sago, not just tapioca, but sago. And I need to get like rose water, and I need to like pandan. So, it's kind of like, it's similar to people who have bambara as their traditional and home crop. I think it's kind of a sense of security, a sense of, oh, I'm very familiar with this crop. It's very comforting to a certain degree.
Yeah, wonderful. I was very inspired by your work. I really wanted to ask you, if anyone else has got a question, please post it. But I wanted to ask you, you've submitted, well done. Look, congratulations. I'm still on the upward climb towards completing myself. So I think that's wonderful. We've got a couple of minutes. I just want to ask you, what are the next steps for you? What are your goals and dreams from here?
Well, my next step is I'd like to stay in the whole agriculture, obviously, bubble. I'm currently working in plant science. So I work in ARL as well as I work with the cannabis group. I know nothing to do with my PhD, but I'd like to ideally still stay in this underutilized crop, minor crop, world. It's a very limited world, but if you find the right research company, right research group, it can actually be very fulfilling. And what I've learned from this is that you can't just be a one-trick scientist. Like, I'm a trained microbiologist, I'm a biochemist, but I now have to do nutrition and data management, which is something that's totally out of my comfort zone. And I had to learn the concept of ontologies, which blows my mind. I'm like, what is this? Ontology, control vocabulary. I did not know how important that was. So yeah, I think moving forward, I'd love to still be in grain legumes, not bambara specifically, any grain legumes, because I think legumes are very important to agriculture as well as human health and also the planet, because legumes,
Yes.
nitrogen, therefore you lessen the nitrogen load that you need, less synthetic nitrogen that you need.
Yeah, looking after our soils as well, which is absolutely vital.
And also because that's why traditionally cereals and legumes are consumed together in a lot of traditional dishes, because they complement each other nutritionally as well as from the perspective of growing and soil health.
Wonderful. Well, thank you so much for your presentation today. That was absolutely wonderful. And congratulations on completion again. Look, that's an unbelievable achievement all by itself. So congratulations, and do stay around. And thank you for coming to Praxis and presenting. I like to find out a little bit more about things that I just haven't heard about, and people that I've never met before. So lovely to meet you.
Lovely to meet you.
And lovely to hear about the wonderful work that you're doing.